Hello everyone, my name is Christian and this will be the part I use for my computer-aided manufacturing's final. This part comes out of the senior design capstone project that I was a part of. There are quite a few different features and processes that went into making this part. It was done by hand on manual equipment for our senior design project, but I thought it would be interesting to set it up to be done on a CNC machine. Here is an early animation of what the internals of this part will look like when it's running. There's meant to be a spring on the back of this little plunger returning it, but it's not in this simulation. The senior design this was built for is kind of bigger picture, but basically we are taking a metal strip and turning it into a finished part. Here is a video of our actual senior design project with the part actually installed and working. We'll just run it from the beginning. So now that you've seen what this is built for, let's go through how I actually set it up in CAM to be built. So starting with the stock itself, the stock did have to be made oversized in the lower and the negative Y and the negative X direction to fully encompass this circle, because it would have been near impossible to make a circle that needed to be this precise on two edge pieces. As far as the rest of it, assumed stock was built down to final size. So first I go in with a centering drill just to get the spot picked out, and whenever we switch to our spade drill, it does not, or our normal twist drill, it does not just walk around on the surface of the part, it actually has a spot to go into. Then we drill a pilot hole with a 1/2 inch drill bit. This was larger than what I wanted, but it was one of the only ones I could actually find in this tool library that could go all the way through the part. Then we move up to a 31/32 drill bit, and that just gets us near final size, which is 1 inch diameter. Next step is actually running a boring bar that is built to run between 1/2 inch and 1 inch. For this simulation, I set the boring bar at 0.995 inches, which leaves us 5/1000ths of an inch under for our next step. And the final step is reaming the part, which is a operation that's just designed to remove very little bit but give you a very nice surface finish and a very consistent hole diameter all the way through. So that is it for the 1 inch diameter hole of this portion. So next we move on to the right face here to drill or to create this geometry here in the center of our part. Again, starting off with the center drill because this is a important piece and we don't want the drill bit walking around before it finally bites. At which point move into a 242 drill bit, which is a special undersized drill for reaming a 1/4 inch hole, which is going to happen later. It's close, but it does work. Drill all the way down to about halfway through the cylinder here. Next we switch over to a I forget what size that drill is. It is the drill so you can create a 1/2 by 20 thread in the part, which you can see in this upper section of the hole. But now that we removed the majority of that material there, move over to the reamer and ream the center section, which this needed to be reamed to act as basically a guide for the piston plunger that we've seen in the animation earlier. And then the last thing we do for this hole is make the threads, like I said earlier, 1/2 by 20, and they're 3/4 of an inch into the part. The last thing we do on this side of the part is we drill 2 more holes at, I believe it's 201, a number 7 drill bit, on either side of our main hole here. And this gives us these 2 holes that we are going to tap 1/4 20 for the shear blade to mount onto. That's all the machining we're going to do on this face. From that point, we move up here to the top section. And it's just another 2 1/4 20 holes, but these ones are only a 1/2 inch deep. These holes are for mounting it to the upper plate that was in the video earlier, the one with the red band on it. And sorry about the stutteriness. If I just hit play, my toolpath simulation is very fast and skips parts for some reason. I'm not sure why. You will see 2 more holes up here on the top. This is not actually machined while the part is outside of the mounting plates. What these are for is for when you mount this block into the mounting plates with these 2 holes and get it exactly where you want it using shims or just tapping it, because there is tapping it on either side to move it thousandths of an inch. Once you get it precisely where you want it, you set the whole thing up in a mill, drill through the top plate into the bottom one to create these holes, ream through all of it, and then put in locating pins, and that will force this block to stay in that location indefinitely. But now we have to deal with all this excess material we had to keep to get this hole drilled. So from there, move over to a facing operation. To bring it down to final size. Then we change setups in the mill. It's going too fast. And start facing down this side. And that leaves us our finished part. That was about 2 weeks worth of work doing it on the manual machine. I believe it probably could have been done with maybe a day or 2 with setup in a CNC mill, or a properly equipped CNC mill. There was some specialty tooling required to make this part. Thank you guys for watching, and we have a good rest of your day.